Okay, we've got two cars following a couple of paths here. Uh, most they can do is a normal acceleration of 0.8 g's. And it wants me to determine the time for each car to negotiate the turn from CC. Okay. Notice what happens here is the outside car starts turning immediately, whereas the inside car travels a little bit, then goes around the curve, then travels straight for a little bit. Okay. So what I think I will do is I'll actually start with what do we have here? Car A, okay, which is the outside car, okay? So what I need to recognize right off the bat is we're going to assume that my tangential acceleration is 0, that these are traveling at a constant velocity, okay? And that my normal acceleration is then v squared over rho, which for both cars will be 0.8 g equals v squared over rho. Now, there'll be different rhos for each one, but the g will be the same, and from that, we'll be able to figure out what the velocity would need to be. So for A, that velocity is 0.8 times 9.8 times VA squared. And again, this one travels around an 88 meter radius curve. Okay, so the velocity of car A is 26.3. Okay, same thing for car B, same acceleration. Okay, but this time this velocity is going around a curve that's 72 uh, meters. So B, the velocity of B is a little bit less because it's a tighter curve. It can't go as fast around the curve, but of course the curve is shorter, so there's a trade-off there. Okay, so let's talk about the distance traveled of these two guys. Okay, so let's talk about the distance traveled of A. A is just going around a semicircle from C to C, right? So the arc length is essentially the radius times the angle, okay, which for our purposes will be pi. Okay, and I need to do this in radians. Degrees won't work for this. To find arc length is the radius, which for us will be 88, okay, times the angle in radians, which is pi that it travels, which is approximately 276 meters. Let me put these, this is meters per second, the velocities, okay? So the distance traveled of A is 276 meters around from C to C, okay? Now, B, again, has a little straight path, right? B has these two little straight paths, okay? And those are going to be 16, which is just 88 minus the 72. So it travels 16 meters, then goes around the curve. This curve will be 72 pi, because its radius is only 72, plus another 16 meters on the top end of the curve, okay? So the total distance traveled of B is 258. So notice, even though it's not going around the curve, uh, even though it has straight paths and not just the curve is smaller enough that B actually travels a shorter distance, okay? But remember that their velocities are different. So now we need to figure out essentially what the time is, okay? Where that time is going to be basically the distance traveled divided by S. I'm sorry, the distance traveled divided by B, right? So the time of A is going to be 276 divided by the velocity of 26.3. And from that, I see that TA is going to be 10.5 seconds, okay? And TB is going to be 258 divided by 23.8, and that's going to be 10.9 seconds, okay? So even though A travels a further distance, the fact that it can take the corner at a higher speed because it has a bigger radius of curvature means that it can get around that corner quicker than B, about 0.4 seconds quicker.